Okay, good day. For today, our lesson is about the trigonometric graphs. Okay, so for today's lesson, we're about to determine the domain and the range of the different circular functions. And at the same time, we're going to graph the six circular functions with its amplitude, period, and phase shift. Okay, so also, I'll recommend you also to use the Desmos for the verification and for you to see the whole graph of the circular functions. Okay, so in our discussion for today, we're going to sketch. Okay, we're just going to sketch the graph. But if we're going to see the uh, graph, okay, of the actual graph of the those circular functions, those trigonometric functions, you can use the Desmos. Okay, so first off, let's discuss first about the graphs of the sine and the cosine. Okay, so initially we have this sine and cosine functions defined in terms of the coordinates p, x, comma y, and it follows that their values are unchanged. Okay, if you are going to remember our lesson about the unit circle, we identify the values of both the sine and the cosine using the coordinates, okay, x and y. Okay, in addition, any integer multiple by 2 pi is just repeated, okay, repeated values. So given that we have sine of x plus 2 n pi is just the same as sine x for any integer n, so as with the cosine. Cosine x plus 2 n pi is equal to cosine x for any integer n. Okay, so you need to recall about our special angles as we determine the sine and cosine values. Okay, so for the graph of the parent function of the sine and the cosine, we have here in the first figure the graph of the y is equal to sine x. So as you can see here, if you're going to identify its values, if we're going to evaluate that, let's say sine 0, that is 0, and then sine pi over 2, yeah, that is 1, and then sine pi is 0, sine 3 pi over 2 is negative 1, and then sine 2 pi is 0. Okay, so as you can see here, when it comes to the graph of the sine and also with the cosine, one period is from 0 to 2 pi. Okay, and also remember, we're going to use the radian, okay, instead of having the degree. So in your calculator, make sure you have your setup it as in for radians. Okay. Another one for the parent function of the cosine x. So as you can see here, if we're going to evaluate, let's say cosine 0, that is 1. So as you can see here. And also cosine pi over 2 is 0. Cosine pi is negative 1. Cosine 3 pi over 2 is 0. And cosine 2 pi is equal to 1. And, okay, so as you can see here, we can identify some of its properties. One of it is the minimum and the maximum value. So as you notice here, both the sine and the cosine parent function, the maximum value here is 1 and its minimum value is negative 1. Okay, and when it comes to the its domain, so as you can see from left to right, we can say that this is continuous and we can say that this is all real numbers. And at the same time, with the range, so looking it from down to up, that is from negative 1 to 1 inclusive. Okay, so again, the domain is all real numbers and the range is from negative 1 to 1 inclusive. Okay, so in summary, when it comes to its properties, the domain is set of all real numbers. the range is the set of y values such that y is between from -1 to 1 inclusive. The maximum value is 1 and the minimum value here is -1. The graph is a smooth curve and each function cycles through all the values of the range over an x interval of 2 pi. Then lastly, the cycle repeats itself indefinitely in both directions of the x-axis. So we have here two concepts to remember when it comes to the sine and the cosine. The first one is the amplitude, and then another one is the period. So the absolute value of A is called its amplitude. Okay, it dictates the height of the curve. Okay, so as you can see, if we multiply constant there, a value, uh, it will reflect to its height, the minimum and the maximum value of the function. So if the amplitude is between 0 and 1, the graph shrinks vertically. And if the amplitude is greater than 1, the graphs are stretched vertically. So as you can see, it stretch if it is greater than 1. And whenever you have a case that you have a negative value for the amplitude, all you need to do is to reflect the graph in the x-axis. And then for the period of the function is the x interval needed for the function to complete one cycle. Okay, so in its nature, when it comes to the sine and the cosine, its period is 2 pi. Okay, but if we're going to have this form y is equal to sine bx and y is equal to cosine bx, where b is not equal to 0, the period is equal to 2 pi over the absolute value of b. If the b is between 0 and 1, the graphs are stretched horizontally. But if it is greater than 1, it shrinks horizontally. Okay, so take note of this, the amplitude and the period. Let's have its illustration. So for the amplitude, so as you can see here, given that we have the parent function y is equal to sine x, so let's say we have here a as 1/2. Okay, so as you can see here, given that a is 1/2, the graph shrinks vertically. In another case, let's say y is equal to 2 sine x. So given that a is greater than 1, the graphs are stretched vertically. Okay, from its parent function. And also, let's say we have 4 as our amplitude. So as you can see, stretch vertically. And if we're going to have a negative value for our amplitude, all we need to do is to reflect this. Okay, let's say we have y is equal to -4 sine x. So all you need to do is to reflect it in the x-axis to have its illustration, its graph. In addition, for the period of the function, so given again its cases, let's have its illustration. So given that we have the parent function for sine 2x, its period is from 0 to 2 pi. If we're going to include again a b here, let's say we have here sine 2x. Okay, so instead of the period of 2 pi, we need to use the value of b, which is 2 here. So 2 pi over 2, which is pi. So therefore, the period of the function is pi. So as you can see here, if b is greater than 1, the graphs are shrunk horizontally. So comparing the function y is equal to sine x and y is equal to sine 2x. So as you can see, it's shrunk horizontally. So given that we have here another example, the y is equal to cosine x and its period is 2 pi. So let's say we have here cosine x over 2. So as you can see here, we have b of 1/2. So 2 pi over 1/2. that is 4 pi. Okay, so therefore the period for cosine 1 half x is 4 pi. So given that the b is between 0 and 1, the graphs are stretched horizontally. So as you can see in the second figure, the graph stretch horizontally. In addition, what if we have here a negative angle? So let's recall the odd and even function. So let's say from the even function, cosine negative theta is equal to cosine theta. And for the odd function, for trigonometric functions, we have sine negative theta is equal to negative sine theta. Okay, so if we're going to apply the odd and even function here, we're going to describe the graph, the nature of the graph of y is equal to sine of negative x and y is equal to cosine negative x. So first off, we have here y is equal to sine of negative x. So obviously, as you can see here in its properties, in its odd function, this will become negative sine theta. And if you will recall, if you have here a negative value, all you need to do is to reflect that in the x-axis. Okay, so let's say its amplitude is negative 1. So, no, the value here is negative 1. So, obviously, all you need to do is to reflect that. But its amplitude is 1. Okay, so the graph of y is equal to sine negative x is the graph of y equals to sine x reflected in the x-axis. In addition, for cosine negative theta or cosine negative x, all you need to do is to use the graph of the cosine theta function. It is the same. Okay, so as you can see here, the graph of y is equal to sine x. In order to have or to illustrate the graph of y is equal to negative sine negative x, all you need to do is to reflect its graph in the x-axis. Let's apply the concept of the amplitude and the period in this on the following examples. So the first example here is y is equal to 2 sine 4x. So obviously, as you can see here, we have the amplitude which is equal to 2. And our period here is 2 pi over 4, wherein our RB here is 4. So 2 pi over 4 is pi over 2. So therefore, our period or our interval is from 0 to pi over 2. And we need to divide it by 4 equal parts. So in order to obtain the 4 equal parts here, so from the 0 and pi over 2, all you need to do is to identify its average. Okay, so to obtain its average, all you need to do is to add them and divide it by 2. So 0 plus pi over 2, that's pi over 2, and divide it by 2, that's pi over 4, which is the third value here of x. Okay, in addition, for you to identify the second and the fourth value here, all you need to do is to average the first and the third value of x here. So 0 plus 4 over pi over 4, that's pi over 4, and divide it by 2, that is pi over 8. Okay, that is for the second value of x. And then for the fourth value of x, all you need to do is to identify the average of the third and the fifth value of x here. So pi over 4 plus pi over 2 divided by 2, and the result of that is 3 pi over 8. Okay, so now, so given this 5 points, 5 values of x, let's substitute it to our function y is equal to 2 sine 4x. So if we're going to substitute that 0 here to x, that is 2 times sine 4 times 0, and 4 times 0 is 0, and sine 0 is 0. So 2 times 0 is 0. And then 2 sine 4 times pi over 8, the result of that is 2. Okay, then for 2 sine 4 times pi over 4, that is 0. And then 2 sine 4 times 3 pi over 8, that is negative 2. Then lastly, if we're going to substitute pi over 2, that is 0. Okay, so use your calculator for you to evaluate this, or you can use our special angles in this case to identify its value. Okay, so after that, you can now plot these points and then observe its behavior. So by its properties, it's a smooth curve. So if we're going to graph this, we'll have that 0, comma 0, pi over 8, comma 2, pi over 4 comma 0, 3 pi over 8 comma negative 2, and then pi over 2 comma 0. So after you plot them, all you need to do is to extend them, and then you're going to see the graph, the sketch of the graph of y is equal to 2 sine 4x. Then you can extend both sides by the same behavior from 0 to pi over 2. Okay, so as you can see here, given that our amplitude here is 2, the height, the maximum and minimum value is changed. So as you can see, we have here our maximum value of 2, and our minimum value here is negative 2. So that is the graph of y is equal to 2 sine 4x. And then for y is equal to negative 3 cosine x over 2, the amplitude here is, again, the absolute value, which is 3, while the period is 2 pi over the b, which is 1 half. So 2 pi over 1 half, that is 4 pi. So again, same procedure. From 0 to 4 pi, we need to identify its 4 equal parts. So as you can see, again, all you need to do is to identify its average of the first and the last one, which is 0 and 4 pi. So 0 plus 4 pi, that's 4 pi divided by 2, that's 2 pi. And then for you to identify the second and the fourth value, all you need to do is to average the first and the third value for the second value, and then the third and the fifth for the fourth one. Okay, and with that, the result is 0, pi, 2 pi, 3 pi, and 4 pi. So again, all you need to do is to substitute the values of x here in our function for us to identify y coordinate here. So if we're going to substitute 0, that is negative 3. And then negative 3 times cosine pi over 2, that is 0. And then if we're going to substitute 2 pi, the result of that is 3. And then for 3 pi, that is 0. Then last one for 4 pi, that is negative 3. So after you identify the 5 points here, you can plot it in to Cartesian plane. And here's what will happen. Okay, so we have here negative 3, 0 comma negative 3, pi comma 0, 2 pi comma 3, 3 pi comma 0, and then 4 pi comma negative 3. And remember, this is a smooth curve, so you can just connect it, extend it, both sides. And this is now the graph of y is equal to negative 3 cosine x over 2. Now, how about this one? So given that we have y is equal to 1 half sine of negative 2x over 3. So as you can see here, we have a negative angle here. So we can use the odd function for us to simplify this and follow the general form of the y and the sine function. So we can have here negative 1 half sine 2x over 3. Okay, then after that, we're going to identify the amplitude, the period, and the critical points for us to graph the function. So the amplitude here is 1 half, while the period is 2 pi over 2 thirds. That is 3 pi. So the period is 3 pi. And then from 0 to 3 pi, again, we need to divide it and have a 4 equal parts. And that is 0, 3 pi over 4, 3 pi over 2, 9 pi over 4, 3 pi. And then again, substitute it in our function. Y is equal to negative 1 half sine 2x over 3. And you can use your calculator for you to evaluate this. So if we're going to substitute 0 for our x, that is 0. For 3 pi over 4, that is negative 1 half. For 3 pi over 2, that is 0. 9 pi over 4, that is 1 half. And then for 3 pi, that is 0. So again, plot this, and you will obtain this graph. Okay, so as you can see here, we have 0, comma 0, 3 pi over 4, comma negative 1 half, 3 pi over 2, comma 0, 9 pi over 4, comma 1 half, and 3 pi, comma 0. So plot the points and then extend it, connect it, and then you'll obtain the graph of the function. Now, after we discuss about the amplitude and period, we're going to learn about the shifting of the graph horizontally and vertically. Okay, so let's say we shift the sine and the cosine function with its general form y is equal to a sine b times x minus c plus d. And in cosine, y is equal to a cosine b times the quantity of x minus c plus d. Okay, so we're in A again is still the amplitude, and B is part of the period. Okay, the formula for the period is 2 pi over B. Okay, remember, the formula for the period is 2 pi over B, not B is the period. Okay, it should be 2 pi over B. Okay, then after that, C is the called as the phase shift or the horizontal shifting. Wherein if C is greater than 0, the graph shifts C units to the right. And then if C is less than 0, the graph shifts C units to the left. And then for the value of D, which is the vertical shifting of the graph, if D is greater than 0, then we shift it D units upward. And then if it is less than 0, the graph shifts absolute value of D units downwards. Okay, let's have an example. So given that we have here y is equal to 3 sine x plus pi over 4. So as you can see here, we have a horizontal shifting or the phase shift here. So if we're going to identify its amplitude, period, and the phase shift, we have 3 as amplitude. And then for the period, we have here our b as 1. Okay, so that is 2 pi over 1, which is equal to 2 pi. And then the phase shift here is, if we're going to identify the value of C, so all you need to do is to equate this x plus pi over 4 into 0. Okay, and x plus pi over 4 is equal to 0 is negative pi over 4. So therefore, we have the phase shift of negative pi over 4. So since we are going to shift it uh, horizontally, the period will also change. So instead of starting it from 0, we're going to start it by negative pi over 4. And then for us to identify its end, all you need to do is to add its period. Okay, wherein our period here is 2 pi. Okay, so that is negative pi over 4 plus 2 pi. And the result of that is 7 pi over 4. So therefore, we're going to have our interval from negative pi over 4, comma 7 pi over 4. Then after that, we're going to divide it again into 4 equal parts and we'll obtain negative pi over 4, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Then again, after that, we're going to substitute all the values of x in our function. Y is equal to 3 sine x plus pi over 4. So if we're going to substitute negative pi over 4, the result of that is 0. Because sine 0, negative pi over 4 plus pi over 4 is 0. So sine 0 is 0. Times 3, that is 0. And then for pi over 4, 3 sine pi over 4 plus pi over 4, the result of that is 3. And then for 3 pi over 4, 3 sine times the quantity of 3 pi over 4 plus pi over 4, that is 0. And then for pi over 4, if we're going to substitute that, we'll obtain negative 3. And then for 7 pi over 4, that is 0. Then, after that, again, we're going to plot this. So as you can see here, we have negative pi over 4 comma 0, pi over 4 comma 3, and then we have 3 pi over 4 comma 0, 5 pi over 4 comma negative 3, and then 7 pi over 4 comma 0. And then after that, again, just extend it with a smooth curve, then you'll obtain the graph of the function. So for you to see the shifting of the graph, so given that we have here y is equal to 3 sine x, and then we have y is equal to 3 sine x plus pi over 4, as you can see, it moves pi over 4 units to the left. As we identify the c is negative pi over 4, so we move it pi over 4 units to the left. So as you can see here. Next one. How about this? So y is equal to negative 2 cosine 2 quantity x minus pi over 6 minus 3. Okay, so here we're going to identify again the amplitude, the period, the phase shift, and the vertical shift. Okay, so with this, we have the amplitude of 2, the period of, given that b is 2 here, so 2 pi over 2, that is pi. Our phase shift here is pi over 6. So if we're going to equate x minus pi over 6 to 0, that is pi over 6. And then for the value of d here, for the vertical shifting, so as you can see here, we have it as negative 3. Okay, so again, here it defines as the shifting of the graph vertically. So we're going to move 3 units downward, okay, from its graph. Okay, and then after that, again, we're going to identify its start and end for us to graph that one period. So we'll start at pi over 6. And then for us to identify the end, again, all you need to do is to add the period. Okay, in this case, our period here is pi. Okay, so pi over 6 plus pi, that is 7 pi over 6. Then after that, we're going to divide it again into 4 equal parts. That pi over 6 to 7 pi over 6. That is pi over 6, 5 pi over 12, 2 pi over 3, 11 pi over 12, 7 pi over 6. Then again, we're going to substitute the value of x here. So we have here pi over 6, 5 pi over 12, 2 pi over 3, 11 pi over 12, and 7 pi over 6. We're going to substitute that in our function y is equal to negative 2 cosine 2 quantity x minus pi over 6 minus 3. And that is negative 5, negative 3, negative 1, negative 3, and negative 5. So if we're going to plot this in our Cartesian plane, so as you can see here, it's in the fourth quadrant. Okay, so given that we have pi over 6 negative 5, that is this one. Okay, then pi over 12, that and negative 3, this one. And then 2 pi over 3 negative, comma negative 1, this one. 11 pi over 12, comma negative 3, this one. And then 7 pi over 6, comma negative 5, this one. Okay, so we have now the graph of the function.